Hello, we are discussing about GATE 2004 ECE paper. Look at the circuit shown. Find the equivalent inductance measured between terminals 1 and 2. So the circuit consisting of two inductors along with some mutual inductance indicated with capital M. And it is also indicated the dot convention to measure the mutual inductance. Okay, to measure the mutual inductance polarity. First of all, when mutual inductance is existing. Mutual inductance exists when the magnetic field generated by a coil induces a voltage in an adjacent coil. Mutual inductance exists when the magnetic field generated by a coil, that is say L1. L1 is a coil, magnetic field generated by this L1. If it is inducing a voltage in L2 also, then we can say there is a mutual inductance exists. And M is written between these two, that implies L1 can able to induce voltage in L2 and L2 can able to induce, that is magnetic field related to L2 can able to induce voltage in L1. So both L1 and L2 can able to induce voltages in the adjacent coils. And M is the mutual inductance. While writing the effective inductance, we must consider the polarity of mutual inductance. So to know the polarity of mutual inductance, it requires the dot convention. The rule of dot convention says, dot convention rule says that one, if there are two coils and the current flowing through these two coils are going to be say I1 and I2. Okay, say the coils are going to be L1 and L2. If both the currents are going to be entering the dots, that is if the dot convention is indicated like this, if the current flowing through the coils, both the currents flowing through the coils, if they are entering, then mutual inductance is same as self-inductance. So whatever the self-inductance polarity, that will be having the mutual inductance polarity. M and L will have the same polarities. Otherwise, if the current flowing through the inductors are going to be leaving the dots, so if the dots are over here also, if the dots are, this is second case, if the dots are over here, then also mutual inductance polarity is same as self-inductance polarity. Not only this one, okay, you can draw the same thing in this way also. Current flowing through this inductor L1 is in this direction and current flowing through inductor in this one is I2. So if the current direction is, now the dot is indicated over here, by that time both the currents are entering the dots. So in this case also M is positive. Okay. Otherwise, if the dot convention is over here and over here, by that time also, in this case also both the currents are leaving the dots, which means mutual inductance is same polarity as self-inductance. M and L both will be having the same polarity. Otherwise, in other cases, M and L will be having opposite polarity. So now we are going to check about the mutual inductance across 1 and 2. Okay, that is L equivalent between the terminals 1 and 2, that we are writing in this way. First we will write it as L equivalent is equal to L1 plus L2 and mutual inductance generated by M. L1 is M, but for that one, whether you have to indicate the positive polarity or negative polarity, that is polarity which will be same as L1 or not, that you have to check. For that one, we must know the current directions. Current flowing through L1 is I1, current flowing through L2 is I2. Okay, incidentally I1 and I2 are same, but we are going in this way only. Okay, now current flowing through this L1 is entering the dot, whereas current flowing through L2 is leaving the dot. So definitely M must be minus related to M1, and similarly for related to L2 also. Okay, current leaving the L2, current flowing through L2 is leaving the dot, whereas current flowing through L1 is entering the dot. So again it is going to be M minus M. So total is L1 plus L2 minus 2 times of M. So this is equivalent inductance. Equivalent inductance is this one. So the right answer is D. Thank you.